Hi, welcome to this platform for Sensor Academy, either the YouTube channel or the Facebook page. In today's tutorial, we're going to consider physics, particularly science paper 1, in trying to prepare adequately for an exam. If it is your first time on this particular YouTube channel, kindly hit on the subscribe button, turn on the notification bell in order to get notified when next I post any video. If you're watching this on our Facebook page, ensure that you leave a comment, share the video, tag those 2024 GCE candidates that may find this same video very much beneficial for an exam build up reliable preparation. So we're going to use 2019 paper 1 internal exam, and the topic at hand is radioactivity from section B. Our question is from B9. So when we talk about radioactivity, we're trying to talk about the breakdown of the unstable nucleus of a radioactive isotope. So this question says the symbol U with a mass number of 238 and proton number of 92 represents a nucleus of uranium with a nucleon number 238 and proton number 92. A. State the meaning of nucleon number. So this 238 is called the mass number. At the same time, it's also called the relative atomic mass. At the same time, it's also called the nucleon number. Then this 92 is the proton number, can also be called the electron number, can also be called the number of atoms. So when the question says state the meaning of nucleon number is the total number of protons and neutrons in the nucleus of an atom. So we're going to say nucleon number. Nucleon number is the total number of protons and neutrons in the nucleus of an atom, or rather an element. So you can say nucleon number is the total number of protons and neutrons in the nucleus of an atom. And then we proceed. So we've got a question on B which says a nucleus of uranium 238 decays to form a nucleus of thorium by the emission of an alpha particle. An alpha particle is a positively charged particle, and when we talk about an alpha particle, we're talking about the nucleus of helium. So whenever in an exam they keep a mention of emitting an alpha particle, we should know that they are talking about helium, and helium on the periodic table is with a mass number of 4 and a proton number of 2. So this would be the nucleus that we'll be referring to as an alpha particle. So now the questions that are following are trying to say state the proton number of an alpha particle. So the proton number of an alpha particle is going to be a 2, being for the reason that proton number refers to the bottom number. So here we're going to ensure that we're going to say a 2. Then the nucleon number of an alpha particle here, it is going to be a 4. Then the proton number of thorium and the nucleon number of thorium isotope, we're going to find that we will need to make that is a decay equation. So what we're given is that is uranium. It had a 238 and that is a 92 here. So when it emits an alpha particle, it's going to emit the nucleus or the atom of helium, and then plus we're going to have a thorium here. So when the numbers are positive here and that they do not have a negative, we are simply trying to subtract. So 238 minus that is 4, we're going to get that is 234. Then 92 minus 2, we're going to get that is a 90. So if at all they told us to find or to state the decay equation, we would come up with this. Now they're trying to ask, find the proton number of thorium. Proton number is going to be 90. And then the nucleon number of thorium is going to remain with a 234. And having done that, it simply means we've answered the question according to the expectation. So an alpha particle is a positively charged particle, or it is a proton. And when we are told to like write the decay equation, we're supposed to write the element being given, then the emission that it emits. When they say alpha particle, you write helium, the 4 here and the 2, then you subtract. If at all these were negatives, we would have added, because in science, positive means subtraction, or we're going to talk about losing. Having done that, it simply means we've understood the task of answering this kind of the question under radioactivity. I hope you find this video very much beneficial. Consider subscribing, share the video, relate the same information by grabbing a paper and revise a lot. Keep believing in yourself. Till in the next video, for now, it's a very goodbye.